This is Emily Whitehead. 10 years ago, Emily received an experimental immunotherapy for the treatment of an aggressive and rare form of leukemia. Amazingly, 10 years later, she's still completely cancer-free. We're at a moment now where, thanks to immunotherapy, curative treatments for cancer are possible. Immunotherapy involves harnessing our own immune system and retargeting it to kill cancer cells. However, if Emily had been diagnosed with a solid tumor like pancreatic cancer or lung cancer, her prognosis might have looked significantly different. That's because in solid tumors, we have to deal with an immunosuppressive tumor microenvironment. As you can see in the bottom left corner, a cold tumor is one that excludes immune cells and in which an inflammatory anti-tumor response is very difficult to mount. On the other hand, a hot tumor is one in which immune cells are able to enter into the tumor and actually mount an inflammatory response. So in order to make immunotherapy more conducive to an actual therapeutic context, we want to be able to convert cold tumors into hot tumors. And to do that, we can take advantage of the natural language that immune cells use to communicate with each other, called cytokines. These are small soluble proteins that can either ramp up or damp down the immune system. However, pro-inflammatory cytokines can be extremely toxic when injected systemically into a patient and have actually caused fatalities in clinical trials. My work harnesses the spatial precision of focused ultrasound with genetic circuits that enable the harnessing of that focused ultrasound to induce a biological response. So using focused ultrasound has a high degree of spatial resolution, and we can target a 2 millimeter region. Additionally, with focused ultrasound, we can induce hyperthermia, which actually induces a local elevation in temperature. That elevation in temperature doesn't actually destroy the tumor, but it acts as a switch, just like in electronics, and it catalyzes a DNA inversion. After that DNA inversion, a pro-inflammatory cytokine, in my case called IL-12, is able to potently stimulate T cells. We're currently working on testing this in mice, and our goal is to be able to create a system in which we can inject engineered cells into a patient, and then the user, physician, will be able to selectively define where and when an immune response is going to be mounted. Our goal is to make sure that cases like Emily's can be realities for patients with cancer, no matter what their type is. Thank you.